note page 99 with you. It will roll over onto page 100 if you need more room for examples, and there are a few things to jot down on page 100 also. So let's just take a look here, thinking first about how quotient of powers works. Quotient of powers with the same base can be found by just writing it out. So if we just think about it logically, writing it out, if we wrote out a to some number of factors, right, we'd have a whole bunch of a's here, and then divided by a to the n and be a whole bunch of a's, and we could cross out whatever ones were in common. By the way, you don't really need to write anything down yet from this page, just hang out and listen. And then at the end, there would be some left over, whatever ones didn't cancel out. And the ones that didn't cancel out, those would be the difference between the number of a's on the top and the number of a's on the bottom, right? So we have a whole bunch of foos, and then we have whatever's left over. It could be in the denominator or in the numerator. So let's write the rule down, the property down in that first space on page 99. And let's get that other thing out of the way for you. So the quotient, feel free to abbreviate, of two non-zero powers with the same base equals the base raised to the difference of the exponents. And feel free to pause the video so that you have enough time. Look, I had an example here before. Maybe I'll erase that and do a new one in a second. Okay. So if we had something like 6 to the 7th divided by 6 to the 4th, we would have 6 to the 3rd. We would subtract them. Okay. And then we have over here on the right, we have the algebra, right? A to the m divided by a to the n equals the difference between m and n. So if we had variables, right, something that looked like this, right? You can think about it just written out. This is always, remember, just like with multiplying, there's always going to be sort of a brute force way to do it. And at first, if you need the brute force way, go for it, because it'll really help you understand where those rules are coming from. And then we would just take our pen and we would cross out all of the fancy forms of 1. And whatever doesn't cross out, that's our answer. So we have 2 x's up top and 3 y's below. Now, right, the rule, the property, is meant to be a shortcut, so that you can see x to the 4th minus x to the 2nd is x squared. Y to the 2nd minus y to the 5th is y to the negative 3rd, which means that's going to have to drop back down into the denominator to be y to the positive 3rd. I must say that I don't always use the rule. I usually just look at where there's more and keep them there, right? So I think of it as 5 minus 2, and that's going to be y to the 3rd power on the bottom. So let's try a couple. Woo, crazy computer. And let's delete them out. I thought I deleted all these before, but apparently not. Okay. Even if you quickly saw the answer. Now you can try them again. Let's jot these down. You can do it at the bottom of the paper or up by the box, whatever is easier for you. 2 to the 7th divided by 2 squared. Right, we have 7 2's up top, 2 on the bottom. Once we get rid of the 2 that are in common, we have 2 to the 5th left over, or 32. X to the 4th over x to the 3rd is just x to the 1st power. Those ones are so easy. Right, I know you can do those, but they are going to get harder. Here we go. Already they start to get a little more complicated. Go ahead and write problem C down. D to the 4th e cubed over de squared. Anytime we have parentheses, right, that comes first in the order of operations. So we have to deal with that part before we deal with anything else. We have d to the 4th e cubed over de squared is de times de, right? Or you can think of it the distributing way. So we get d squared e squared. And now we can cancel out d's in common. So here's how I actually usually write it even. I think of it as being, well, I've got 2 d's downstairs, those are gone, and the 4 changes to a 2 because the 2 shared d's are out of the way. So I have d squared left, and I have e squared under e cubed, so both of those e's disappear, and this e to the 3rd power becomes e to the 1st power, or just e. So I like to do it more like canceling than subtracting. That's just my preference. Write down problem D. It's all numbers, which probably means we should give a numeric answer at the end. Now you could do it the long hard way, which would be multiplying it all out, or you could do it the quick easy way, which would be by canceling common factors. So I have 1 3 up top and 2 on the bottom, so I get rid of 1 from each of those places. 4 4s on the bottom, 3 on the top, so I get rid of all of those, and I get rid of 3 of the 4 on the bottom, so I just have a first power. And 5 to the 5th divided by 5 to the 3rd. I'm going to get rid of all 3 from the bottom, and this becomes a 2 because I have 2 left over. So what I'm left with is 5 squared over 3 times 4. You do have to write really neatly so that you can see what you have. It gets a little confusing. So I end up with 25 over 12, and that would be the simplified answer. It is possible to split up a quotient of products into a product of quotients, meaning you can break it up from being one big fraction with multiplication into 2 smaller fractions. That's totally legal, totally fine, as long as what's in the numerator stays in the numerator and what's in the denominator stays in the denominator. The order of it doesn't actually matter. And it doesn't matter if it's 1 fraction or 2. So that's just a little reminder. Whoa, I don't know why all these are filled in. I thought I erased them all. All right, so here we go. Scientific notation, everybody's favorite thing. We did multiplying before, now we're going to do dividing. And we're going to simplify 3 times 10 to the 10th divided by 6 times 10 to the 6th. Write it as a fraction first. And now that you've written it as a fraction, you can use what the previous slide was saying, and you can actually break it up into 2 math problems. 3/6 times 10 to the 10th divided by 10 to the 6th. So 3/6, well, that's just 1/2 or 0.5. And 10 to the 10th divided by 10 to the 6th is 10 to the 4th power, subtracting or getting rid of all the ones that are in common. Now that's not quite in scientific notation because we have to have 5, not 0.5. So we need to move this decimal 1 place to the right. And then that means we have to adjust our power of 10. So before, in order to get the answer, I was going to have to move that decimal 4 places. 1, 2, 3, 4. But now I moved the decimal forward 1 already, so now I only need to move that decimal 3 more places. So the answer would be 5 times 10 to the 3rd power. These aren't going to come up that often, but it is on the list of things you're supposed to know. And I think I'm just going to skip that one for now. And let's move on to the second rule, which is the positive power of a quotient. And in a sense, I think we've actually already gone over this year. If we think about what happens if I take a over b and I raise it to the n power, it would mean I have a whole bunch of a over b's all times each other. And so that means I really have a whole bunch of a's all multiplied together, n of them, and I have a whole bunch of b's all multiplied together, n of them. So I could have just written it as a to the n over b to the n. Right? So it's kind of like I take the exponent and I make it distribute to both the numerator and the denominator. Get ready to write, get ready to pause it potentially. The words are kind of long. A quotient raised to a positive power, and it does matter that it's positive, okay, because right now, because there is a separate one for when it's negative. Quotient raised to a positive power equals the quotient of each base raised to that power. Algebraically, it's a over b to the n power equals a to the n over b to the n. And you've got that numeric example there. 3/5 raised to the 4th power is really 3 to the 4th power over 5 to the 4th power. And as long as that fraction starts out reduced, it's never going to cancel any more than that. Okay, pause it if you need more time. Okay, first example. Write it down somewhere at the bottom of the page or on the back side. 3d squared all over ef raised to the 4th power. So every single thing in the parentheses needs to be raised to the 4th power. Let's write it out that way before we even start simplifying all the rest of it. So we've got 3 to the 4th power, d squared to the 4th power, e to the 4th power, and f to the 4th power. The only thing that I can really do anything with, besides the 3 to the 4th, and I can write that as 81, is d squared raised to the 4th power, which is d to the 8th power. That's using one of the rules you learned in the multiplying section, 7-3. And then the bottom stays e to the 4th, f to the 4th. And that's it, simplified. There's nothing else that cancels because all the variables are different. Even a little bit more complicated here. So write it down, pause the video, see if you can figure it out on your own before you come back. Okay, you're back. Let's see what it looks like. Always start with the parentheses, the innermost parentheses first. So I know I'm going to have to raise 2x cubed to the 2nd power. I know I have to raise x, y to the 3rd power. So I'm going to do that part first, x cubed, y cubed. And I still have to, actually let's do this, let's fix this. So the whole thing is all raised to the 2nd power. Okay. Now it's like I'm taking 2 of them next to each other, and remember, if that helps you to write it out, by all means, write it out. Okay, and then you can multiply the 2 2's together. Otherwise, you can use the shortcut, right? We're going to go ahead and do 2 squared is 4. X cubed squared is x to the 6th. And the bottom also. Move it down here if it helps you. X cubed squared is x to the 6th. Y cubed squared is y to the 6th. And now I have x to the 6th in both places, so I can get rid of that. And I end up with 4 over y to the 6th power. Some of you are thinking ahead. You're probably thinking, hey, how come you didn't cancel the x to the 3rds here? I could have. I just didn't even think about it. And then I would have only had 2 over y cubed, and I would have just squared each of those. Okay, you can cancel whenever you want in the process, as long as there's no parentheses left trapping things. So make sure you've got things outside of the parentheses. Last rule, and we're going to pull them all together. The last few problems are pretty tricky. They force you to use everything from 7-3 and 7-4. Negative power of a quotient. Okay, this is a little bit tricky. A quotient raised to a negative power equals the reciprocal of the quotient raised to the opposite power. Quotient raised to a negative power equals the reciprocal of the quotient raised to the opposite or positive power. So what it looks like, and I'll explain why in a minute, is that you flip the fraction and you make the power positive. Why that is pretty cool. Okay? Complex fractions, I know, aren't most of your thing, but stick with me for a moment. Okay? Let's do one that's slightly different than this one. Actually, no, we'll do the same one. It'll explain it. Okay? So we have 2/3 to the negative 4th power. So what this really means is that I have 1 over 2/3 to the positive 4th power, right, which is called a complex fraction. So I'm going to deal with the bottom part first, and I'm going to raise each of those to the 4th power. So I end up with 2 to the 4th power over 3 to the 4th power. Now I'm going to write my division out horizontally so that I can actually see it. 1 divided by 2 to the 4th over 3 to the 4th. When I divide by a fraction, remember I have to flip and multiply. So I end up with 1 times 3 to the 4th over 2 to the 4th. And obviously 1 times anything is that something itself. So we end up with 3 to the 4th over 2 to the 4th power. So rather than going through all of that every time, which you can, it's the long cut, but it sure works, right? We have a shortcut, which is to memorize that when you have the negative power of a fraction, you flip the fraction over and make the power positive. And then you distribute that power just like you would anytime you have a positive exponent on a fraction. Okay. Now before we do the examples for this, let me just remind you, now that you're on the almost to the bottom here, is on page 99, you've just filled all that in. On page 100, there's all the little algebraic parts in the box, and all they want you to do there is fill them in with the answer. So like for this part, a over b to the negative n, you would write what I am circling right now, which is, right, b to the n over a to the n, or actually I'd probably even write both of these things. B over a to the n power, which then equals b to the n over a to the n. So you can just look those back up and fill them in from the algebra box of each of the 3 rules. So let's try some of these hardest examples that mix all 3 rules along with rules from yesterday. Okay, this first one's not so hard actually, but we're going to get there. 3 over 4 to the negative 3rd power. I flip and I raise to the positive power of the same thing. That's it. Write it then. Using today's rules, you can't have any parentheses in your final answer. You have to distribute that out. You can leave it like that, or you can go ahead and multiply it. 64 over 27. 3 times 3 times 3. Yeah, 27. No idea why I didn't delete any of these. I looked through this already. I'm not sure what happened. 2x squared over y cubed, all raised to the negative 2nd power. So the first thing I always do is get rid of that negative power. So I'm going to flip it all over. Oops. Undo, undo. There we go. So we put y cubed on the top, and now we have 2x squared on the bottom, and it's raised to the positive 2nd power. Flip and make the exponent positive. Flip and make the exponent positive. Now distribute that squared so that each the numerator and the denominator get to have some of the squared, and we have y to the 3rd squared is y to the 6th, and we have 2x squared, which is 2 squared is 4, x squared squared is x to the 4th power. And really, no shame in writing it out if that still helps you. Right? Do what it takes to get the right answer. Right? And then you can really see where that y to the 6th comes from. Multiply your 2's, add up the 4 x's, and you're done. Doesn't take a lot longer. Oh look, it's one I finally didn't do. Ooh, because it's the challenge example. Jot it down. I'll leave it up here for a second, and try this one. I'm going to give you the answer tomorrow. Hang in there. It's tricky. You can do it though.